technology has been rapidly evolving over the past decades, giving us the ability to do things that used to be impossible. Applying technology to all aspects of human society is one of the major global trends that shape our modern life. To keep pace with the evolution, universal semiconductor technology has been continuously innovating since the very first day when the facility was put into operation in 1984. With over 30 years relentlessly contributing to the blooming of gallium arsenide semiconductor technology, we have now become a global supplier of foundry services and gallium arsenide-based devices. Together with our customers, we have been inventing, designing, and creating more than 30 million devices per month, improving safety and performance everywhere on Earth. In fact, our advanced processing technology is widely applicable in various fields like defense security, maritime exploration, and communication services to shape the future. This is the microchip that makes the world a better place to live. A microchip is the heart of any electronic device. It looks flat from the outside, but may have more than 30 layers of complex circuitry, like floors of a skyscraper. In general, there are more than 350 steps required to make this little device, and we call the whole process semiconductor fabrication technology. Let's take a look at the raw material before I walk you through one of the most expensive facilities in the world where this microchip is produced via complex and strictly controlled processes. Gallium arsenide. This is a semiconductor compound of two elements, gallium and arsenic. These two materials are alloyed at high temperature, 600 to 1300 degrees Celsius, to form a high-purity monocrystalline gallium arsenide ingot. This ingot is sliced into wafers about the thickness of an ATM card. A wafer, also known as a substrate, is the primary component used to manufacture a semiconductor chip. The question is, why do we use gallium arsenide instead of silicon as a compound semiconductor? Having extremely good electrical properties, gallium arsenide transistors are 10 times faster than silicon ones. This is like comparing a steam engine locomotive with a fast modern train. For the last 30 years, experts have been using gallium arsenide-based devices as an alternative to silicon in most mobile phones, satellite communications, microwave point-to-point links, and some defense and radar systems. Once cut from the gallium arsenide ingot and passed through a whole chemical process to make it smooth as well as completely free of dust, 25 gallium arsenide wafers are packed into each hermetically sealed container and sent to clean rooms where the manufacturing process will continue to make the microchips. Clean rooms are the controlled areas inside the fab where our microchips are made. Clean rooms are extremely clean to ensure that the chips can be built successfully. Think of the cleanest room that you have been to. The hospital operating room? Our clean rooms are thousands of times cleaner than hospital operating rooms. Did you know that a microchip could be killed instantly by touching a human hair? People who work in the clean room, therefore, have to wear special clothing called bunny suits. At Universal Semiconductor Technology, we require that all engineers wear bunny suits and go through an air shower to be completely free of particles before entering our Class 10 clean room. Most of the time, the fabrication process will start off at the design center. Our design engineers use special computers to lay out the pattern for each transistor, also called a circuit. And each microchip is made up of hundreds of millions to billions of transistors. By using a technique called photolithography, the multi-layered structure of the circuit will be imprinted onto the wafers. First, the wafer is coated with a photosensitive chemical called a photoresist. In a sealed darkroom, our engineers will project UV light through an image of the design or mask, then through a miniaturizing lens to shrink and imprint circuit patterns onto the surface of the coated wafer. Unwanted areas of material are then etched in either an acid or base solution, leaving the photoresist pattern intact. An extra inspection step is involved at this point to ensure the image transfer from the mask to the top layer is correct. From the photolithographic area, our wafer moves on to a wide range of further process steps like ion implantation, plasma etching, and metal deposition. These take place in 3 different fabs where the electrical property of the transistors will be specified. The steps will be repeated several times until the desired number of layers have been built up and all active devices have been formed. Once wafer processing is complete, each chip on the wafer is tested for electrical performance to ensure that it is performing the operation for which it was designed. In order to assemble the semiconductors, a diamond saw first slices the wafers into single chips. Inked chips are discarded, and the remaining chips are inspected and tested again to make sure they function properly. The approved chips are then packaged. Wires are then attached to these packages, and finally the package is encapsulated in a plastic or ceramic case. From the assembling room, the microchips will start on a new journey to our clients' factories. Here, the chips will go through another technological process before being placed in electronic products. The microchips produced by Universal Semiconductor Technology can be found everywhere around you. From the smartphone you are holding in your hand to the Wi-Fi station at your workplace. From deep down in the ocean to high up in the sky, or even higher than the sky. Space